Right, thank you, Catan. Does everyone know what's happening in Australia at the moment? Does everyone see the news? No? No one knows? Don't care? Pretty much a lot of Australia's been impacted by bushfires, and that's impacted the utility. So I'm going to focus a little bit today about the physical side of networks and digitising networks, as well as the energy, because the impact on the communities when you get this wrong is quite substantial. In 2017, the hurricanes that hit the US and the fires cost $400 billion. Yet we spend most of our time talking about energy and integration of distributed energy resources. They are part of the solution, but there's a few other problems out there to be solved. So, previous to NZN, I was the CEO at Ergon Energy, and I managed the utility that distributed power in Queensland, which is 97% of the state. So quite a large area, not many customers, but a lot of assets exposed to the environment. So what are the things we're trying to solve at the moment? I think it's important we get these right, because without a balanced set of objectives, we typically get it wrong. And can I say, again, from an Australian perspective, we went for an emissions or a renewable target, and that was pretty much a vanilla strategy. The consequence of getting it wrong is higher electricity costs, lower reliability, and reduced safety. And we're actually experiencing that now. We had one of the most reliable, low-cost systems in the world. It's not that today. And how did we get there? So we're trying to deal with emissions, we're trying to deal with renewable intermittency, distributed energy resources, the frequency, intensity of disasters. There's more lives and assets at risk. The high reliance on the connected world and transport. So just this year in California, for instance, they've turned off up to 3 million people to ensure that the networks don't create a fire start. Now, the counter-argument to some of those things is if you look up Wikipedia and find out what the largest amounts or numbers of deaths that occurred in Australia, it related to heat waves. It was heat. And I'm not talking early 1900s, I'm talking about 7, 8 years ago. So how do you keep the amenity of electricity up in this increasing risky environment? So what do we want to do? We want to increase availability, make sure it's affordable, it's secure, it's cleaner, and it's smarter, and it's an enabler for growth. And I say enabler for growth from the perspective that at the moment, industries are shutting down in our country because electricity prices are so high, or they're going elsewhere. So how do we make the renewable portfolio work for business, not against business? And that can be done. Absolutely can be done. Someone mentioned the other day about the computing power of the first moonshot compared to your iPhone. I think when I look at that, it was all about a president who provided a goal and a heap of bloody great engineers and others who got together and made it happen, and along the way created some computing power. What we have in the industry today is lots of people with views on where the industry should go, and therefore we get a somewhat fragmented approach. So a digital utility is a key enabler. So it's all about sensing, seeing, orchestrating and transforming. The transforming bit is around actually changing the organisation to be able to work in a digital world, because we structured it to different processes before. So when we change it to a digital world, things change. We can automate things, we can analyse more, we can change what our risk profiles are. I'm not going to spend too much time on sensing. There's been a lot of discussion about that. I'll put it into some practical examples, but the cost of sensing the network these days is very low. The cost to get behind the meter, the cost to get into the appliance, into the EV is a very low cost. So when I talk about seeing, it's not just seeing with the eyes, it's actually sensing the energy and sensing the condition of the asset and sense what's happening out there. So in the company I ran before, we created a technology which we called ROAMs, and I sometimes struggle to remember what it meant, but at the time it was a remote observation asset management engineering solution, economic solution actually. And what that was about, because Keaton wants me to get some dirt under my fingers, was I was spending $104 million on vegetation every year at that point in time. The efficiency of the business in terms of monitoring asset was good, but I couldn't see the environment. My contract costs were going up. We're at 104 mil. A guy came to me who I had a fair bit of respect for, a lot of time in the IT industry, great asset manager. We are working with collaborative research centres, and came to me and said, we think we can do this. And what that was the mass capture of the asset and the environment, the vegetation, the buildings, the ground, at scale, 160,000 kilometres every year, and that's been now going for 8 years. I focused on a couple of areas. There are 3 fatalities in ergon. When I look backwards, people say, what do you predict going forwards? I can tell you when I look backwards and I apply this technology, those 3 fatalities would not have happened. It was a scoper, a vegetation person up in the Gulf going to scope trees that there were no issues with. We could see that. It was a guy trying to get access to an access track where he went into the bush and got bitten by a coastal taipan snake. Took us 2 hours to find him. Didn't need to be there. There was a painter who hit one of our wires. The wires were too close to the building. I couldn't see that, but now I can. So we did it for safety, we did it for vegetation, we did it for disaster response. And basically what we're doing is mass capture all the way using satellites down to phones, but the initial capture with planes at high level, creating a virtual world. Conflating the enterprise data in there from your SAPs, your ERPs and those sorts of things, because guess what, those things move slow. So we bring them into a new environment, an agile environment, conflate the public data in, the asset risk, the density, the fire areas, those sorts of things. So we start to create a picture. So that picture up on the right, up the top left, that is actually bushfires. It's automatically recognising that non-compliance is out there. It's an automated process in this case. So I'm able to take our people off managing process to managing strategy and application. The other one is outages to the right. It's showing you Sydney, that's around Sydney, where the key outages are. The red, the company gets penalised for that. They can get plus or minus 5% of their revenue by keeping their outages down. The one down the bottom on the left is energy. It's an energy heat map showing you where the energy is being consumed. So when you start to plan, you understand where that energy is being consumed, where do I need to address? It's not a vanilla approach, it's understanding what the risks are, what's causing the issue, and dealing with that. One thing we did with our engineers is said, stop coming to me with a solution, come to me and tell me that you understand the problem first. And then let's work on the solution. The other one on the far right down the bottom is conductor clearances. So we can see when you start to get a lot of distributed energy resource, batteries, hot water storage and all that sort of stuff out there, all of a sudden all those hundreds of thousands of spans become critical. One could be sagging down across a deck or something like that. You've never had that experience before because there's more energy coming back up the network than used to go down it. So all of a sudden you've got clearance issues. And in Queensland, if we don't fix that and we know about it, or even don't know about it, that's go to jail sort of stuff. So I just want to talk about a couple of applications again from experience. I'll focus on the middle one just to start off with. So one of the reasons that we digitised the network and started to change the processes around it was disaster, resilience and response. So when Ergon Energy got hit by Cyclone Larry in 2007, I think it was 31 days to rebuild the network. 31 days. absolutely destroyed, Innisfail, etc. This photo here that's in the middle is a cyclone called Cyclone Marcia. We knew where our asset was in 3D, virtual world, and when this cyclone hit, we had the planes up the next day, and within 24 hours, our planners in the office knew where every defect was, where every tree across the road was, where every house was damaged. Now, in the fires that are hitting Australia now, I'm watching them on television at 7 days later, and they're still saying the utility cannot get in. The fire response people won't let them in yet, it's too dangerous. When we tested the concept in Tassie in the Tasmanian fires, we had the data back within 24 hours after we flew. We flew 24 hours after the fire. So in Queensland, at top end Australia, I knew more about the Tassie fires than the CEO in Tassie did. The thing was, I could see he also had resources working in areas where the houses were gone. Business was not there anymore. So how do you use this data to increase the resiliency of the community as well? You can be the best utility in the world, get that stuff back on quickly, but if there's no business to connect it to, what's the point? So in this case, with Marcia, that response was 14 days. We had vehicles on the road with poles, all the equipment within 24 hours because we could see. We had high voltage generators connecting to the network where the network was there because we could see. We had customers going back on. We were tracking our social media, which spiked on the day that we published all the response schedules saying you'll be back on day one, but day two, etc. Never been done before. We published expectations in the media when they would be on because we could see, because we had a digital model. So just bringing it, and this is the last slide, just bringing it into a current day example. So we're working with a company and then with Endeavour down in New South Wales. Now those black marks, they're not all the fires, they're just there for relativity. You can see Sydney up the top there on the left-hand side. The shaded grey areas are the burnt areas of the bushland in New South Wales. That arrow on the middle slide points to a place that's called Boyley Point. And strangely enough, we've started a project with Endeavour Energy to be able to take Boyley Point off the grid in times of disasters, bushfires, because of the distributed energy resource, putting a DERM system over the top, being able to see where that resource is, putting control of the street lighting, the control of the hot waters. That slide on the right is a digital model from above, so it's not in the 3D sort of overview, but the red dots are hot waters, and the green dots, which is less of at the moment, is solar. The aim for us in this project in the next 2 years is to get solar up to 50%. Australia has the highest penetration of solar on rooftops in the world, and we're having issues with low demand in the middle of the day. So what we're trying to do here is create the energy envelope so the energy is consumed locally, and when a fire comes and takes out those two feeders that supply that area that's quite isolated down there, we're able to run it off the DER. Now there is a reasonably large DER there at 4.8 meg with 2,000 kilowatt hours of Tesla batteries, which is the Willinga Equestrian Centre. But what that does to the community is they don't have to move. They stay there, they're in their jobs, community recovers a lot quicker and gets on with business and grows. Now, if you ever read about Puerto Rico and see what happened when it got hit by that hurricane, how much of the families, the people moved out of there and never come back because there are no jobs, there are no businesses at the time. So when you think about digital, think about customers, the community, and what you can do to help them prepare for these ever-increasing disasters. Thank you.
Thank you very much for that, Ian. One of the important statements that I made earlier in my slide was that digitization and technology is the enabler and the organization was the constraint. And one of the most important reasons for the constraint being the organization was we lost focus on the customer. And I think you brought it out very nicely. Thank you very much for the thing. Mr. Agarwal, before I ask you to take on stage, you run the power grid, so to speak, for our country. And the question to you, sir, is emergency response. I don't think our experiences from Odisha, many other places. If you could share some of your views in those areas, that would be great, please.
During grid operation, because I am not with power grid, I am with Power System Operation Corporation, which is responsible for the grid operation. So during grid operation, we have handled many emergencies, like in Hudud, in Thailand, and many of these. This becomes easy when you are properly planning that. So planning means first we should know that some cyclone is coming. Then first we should know that what is the path of that cyclone. And then planning the outage of electricity in that area. If we could provide some emergency response like ERS. ERS from power grid is used for quickly erecting the transmission which is fall down because of cyclone. So like this we are handling, and then with the coordination of all stakeholders, because whenever there is any emergency in any place, you require the coordination with all the stakeholders. So with the help of all stakeholders, we could handle many emergencies.